12th International Physics Olympiad year 1981 IPHO. I offer a private tutoring for Physics Olympiad preparation. I currently have openings. There is a discount for group classes. Message me if interested. My email is fred1996@hotmail.com and my Skype name is Eduard F 1996. Problem number 3. Detecting astronomical radio waves. A detector of radio waves in a radioastronomical observatory is placed on the sea beach at a height h equal 2 meters above the sea level. After the rise of a star, radiating electromagnetic waves of wavelength lambda equal 21 centimeters above the horizon, the detector registers a series of alternating maxima and minima. The registered signal is proportional to the intensity of the detecting waves. The detector registers waves with the electric vector vibrating in a direction parallel to the sea surface. Question number 1. Determine the angle between the star and the horizon in the moment when the detector registers maxima and minima in general form. Question number 2. Does the signal decrease or increase just after the rise of a star? Question number 3. Determine the signal ratio of the first maximum to the next minimum. At the reflection of the electromagnetic wave on the water surface, the ratio of the intensities of the reflecting field of the refracted ER and the incident EI wave follows the law ER over EI equals n minus cosine phi over n plus cosine phi, where n is the refraction index and the phi is the incident angle of the wave. For the surface higher water for lambda equal 21 centimeters, the refraction index n equals 9. Question number 4. Does the ratio of the intensities of consecutive maxima and minima increase or decrease with the rising of the star? Assume that the sea surface is flat. Solution for problem number 3. Question number 1. The signal registered by the detector A is a result of the interference of two rays. The ray 1, incident directly from the star, and the ray 2, reflected from the sea surface. See the figure. The phase of second ray is shifted by pi due to the reflection by the medium of larger refractive index. Therefore, the phase difference between the two rays is delta equals AC plus lambda over 2 minus AB, which is finally lambda over 2 plus 2h sine alpha. The condition for interference maximum is lambda over 2 plus 2h sine alpha maximum equals k lambda, or sine alpha maximum equal 2k minus 1 multiplied by lambda over 4h, where k equal to 1, 2, 3, etc. till 19. The difference of the optical paths cannot exceed 2h, therefore k cannot exceed 19. The condition for an interference minimum is lambda over 2 plus 2h sine alpha minimum equal 2k plus 1 multiplied by lambda over 2, or sine alpha minimum equal k lambda over 2h, where again we have k equal 1, 2, 3, etc. till 19. So that was a solution for the first question. Question number 2. Just after the rise of the star, the angular height alpha is 0. Therefore, the condition for an interference minimum is satisfied. By this reason, just after the rise of the star, the signal will increase. That was a solution for question number 2. Question number 3. If the condition of an interference maximum is satisfied, the intensity of the electric field is a sum of intensities of the direct ray EI and the refractive ray ER, respectively. So we have E maximum equal EI plus ER, and because ER equal EI multiplied by n minus cosine phi over n plus cosine phi, we have E maximum equal EI multiplied by 1 plus n minus cosine phi over n plus cosine phi, and because phi maximum equal pi over 2 minus alpha maximum, we have E maximum equal EI multiplied by 2n over n plus sine alpha maximum. At the interference minimum, the resulting intensity is E minimum equal EI minus ER, which is EI multiplied by 2 sine alpha minimum over n plus sine alpha minimum. The intensity I of the signal is proportional to the square of the intensity of the electric field E. Therefore, the ratio of the intensities of the consecutive maxima and minima is I maximum over I minimum equal E maximum over E minimum square, which is this expression. Using the equation 2 and 3, the equation 6 can be transformed into the following form. Expression for number 7 is the result when we insert alpha maximum and alpha minimum from the expression 2 and 3. And that was our result. Using this general formula, we can determine the ratio for the first maximum K1 and the next minimum. For the equation number 8, we have K equal 1. It means that I maximum over I minimum equal this expression, and after putting numbers, we have this ratio is about 3 multiplied by 10 power 4. That was solution for question number 3. Question number 4. Now, using formula number 7 and n much greater than lambda over 2h, we have approximately that I maximum over I minimum equal 4n square h square over k square lambda square. So with the rising of the star, the ratio of the intensities of the consecutive maxima and minima decreases. So that was solution for question number 4. And now we did all questions for problem number 3.